Hello, in this video I will show you how to make an ozone generator, and I will also talk about some physics involved. I made few types. So this first one is the condenser stuffed with copper wire and filled with conductive liquid. To the conductive liquid there's one electrode connected, and one electrode is connected to the stuffed copper wire. The idea here is that you can see the discharge, so it's rather a cosmetic design than functional. Also, you could easily connect a tube to the condenser, but the problem is that it didn't work. So I thought that problem was with liquid electrodes, so I made this one, which has similar glass thickness, just for a test, and it did not work. So then I made this one. The inner electrode is more forced to the side of the glass. Also, glass is thinner and there's more wire wound around, so I thought that may be an issue. There are two ways to test if this device works. First one is you smell the ozone. Actually, it smelled pretty easily, just a few seconds after powering. And second one is you can see the discharge as a faint glow, but there's nothing on those three types I made. You can now see that glass thickness compared one to each other. The right side one is about 2 mm thick, and the longer one is about 0.5 mm thick. After this long chain of unsuccess, I made this one. This is made of plastic. Also, inner electrode is aluminium foil stuffed in between the walls of the rolled plastic sheet, so it is perfectly forced to the sides. Copper wire around is just as it is. There is nothing to do very much about it, and it didn't work as well. So I made also this one. There is dielectric material. This is PVC, also stuffed with copper wire inside, and no change, not working at all. So I made this one, and this one is actually the first one I made, and it works pretty well. The only difference between those are diameter of the inner electrode. This one is pretty thin, about, I don't know, 0.5 mm. Then there is dielectric material and wire wrapped around. So I made this one just to confirm that I'm not doing anything wrong. And this one didn't work, so when you compare those two, there's not really any difference. Yeah, the longer one is wrapped around some wooden piece, but it really works also in straight state, any length, so I don't know really, or at least I didn't really know what was happening. This one is a variation on the generator on the wood chunks, so it works really nice. And yeah, I will show you some photos of this. They're pretty interesting. This is shorter time exposure photo. You can see that the glow, it is not very consistent. I don't really know if this is right or not, but I guess no. Here you can see there's actually little tiny places where the discharge is happening and spreading on dielectric material, which is kinda what I would expect, but okay. But long story short, before we start with physics, what I have found is that I was using DC power source. It was flyback from TV, and those modern flybacks has internal diodes, so... But the problem is that how the fuck can any of those work? And there is that one particular type that is working, and I don't really know how. So I read something on the wiki and I came to some conclusion. Okay, so let's see what's going on here. Okay, so we have two sharp electrodes, and at the higher voltages, those sharp points have a really high electric field that may be visualized by those red lines that represents electric field. So there is ionization of air molecules going on, and the current discharge happens. When we modify one electrode and make it not so sharp, the current discharge on one side is eliminated. And that is because the electric force density is lower because it's more spread. Well, also this all happens in ambient air actually, and here I am writing electrical breakdown voltage for air that corresponds to about 1 kilovolt per millimeter. The distance between those electrodes must be greater than 20 millimeters at 20 kilovolts.
Okay man, enough of that bullshit. I apologize to you for my colleague for that crappy narration. We don't want to spend next 10 hours on editing audio. But back to the subject. Let's simplify those electrodes by replacing rods for circular shape. Reconnect them and visualizing electric field lines, we can see that nothing much will change. The reason why we got rid of corona discharge on positive side is that it is not producing much ozone. The negative side and positive side corona have different properties because of different charge and free electron density. However, those two circles will not create very much ozone. We can either have arrays of electrodes, or in our case we can add one dimension to drawing. Now on thin electrode there will be corona formed on whole length. Note that this thin electrode should have about 0.3 mm diameter, and electric field will produce force, which can cause vibrations, even bending at large lengths. As those electrodes should be as close as possible, there is big risk of arc forming. We can add some spacers to prevent this, but this is only adding complexity to the system. We can use dielectric material as current limiting element. Note that we changed power supply from DC to AC. This is because as the insulator is saturated by charged particles, we have to change polarity to let the current flow back. Next benefit is that we can move electrodes almost infinitely close together. As long as there is gas to ionize, the system will work. So this is pretty robust solution. By combination of previous two systems we can use insulated wire as one electrode, wrap thin wire around which is second electrode. Now everybody should agree that this is effectively a capacitor. To reveal mystery, why there was such inconsistency in our experiments, let's draw a schematic of this device. First of all, our experiment was done on DC supply, but here is drawing of AC supply with a capacitor connected to it directly. As you may know, this circuit has its DC equivalent. At fixed frequency a capacitor may be replaced with resistor, so current flowing will be the same. Oops, editing glitch. So most likely this is what's happened. When we go a little bit more into detail, on this picture is drawing of that resistive equivalent. Note that thin wire has also a very good coating that can withstand 20 kilovolts, but it is prone to cracking and mechanical damage. So I think that on those damaged parts of wire a discharge will be formed, represented by green in this drawing. Compared to the real photo, I think that this is real thing. Also, a wire that was used here is from water pump, that was extremely cheap, cable quality was 2 of 10, it was exposed to weather for a long time, so no wonder that it is behaving in such way. Bad thing is, that flyback supply was destroyed during diode amputation. Good thing is, that I have learned something new and bought a plasma ball so I can try use that as power source. I am also not going to do ozonolysis until I have enough knowledge to do it safe. There may be an update to this. I pretty much want to see the condenser generator in action.